And cool. All right. How are you guys doing today? So, my talk today is titled "A Token Walks into a Spa," and it's really a security talk for folks who are building single-page applications. Now, before I get started with the talk, how many of you guys are currently working on single-page applications, whether it's Angular, React, Vue, any of those frameworks? Okay, so about half of you. Awesome. And so for those of you guys that aren't, you'll learn something new. And for those of you guys that are building single-page applications, you might learn some more advanced stuff on how to secure them. So just a little bit about me. My name is Otto Kukic, and I work as a developer evangelist for a company called Auth0. And what we do at Auth0 is basically identity as a service. So we handle all of the complex authentication, authorization, single sign-on, all of that fun stuff that developers absolutely hate building. We kind of do that for you and make it really, really simple to implement and not worry about. So with that said, let's get into single-page application security best practices. Now, for those of you guys that have built spa apps in the past or currently, you know that your entire application typically lives entirely in the browser. So when a user comes to your application, you push your entire application on the front end, and then the front end client, the browser, determines how to display that information, what to display, so on and so forth. And with that in mind, you can't really have any secret keys, you can't have any secret information in your single-page application unless you want somebody to go into your source code and get those keys out, get that private data out, and basically you'll have a non-secure single-page app. So with that in mind, when we're talking about security best practices, there really aren't too many. And I could stop the talk right now, and we can move to the next one. But let's take a look at how we've traditionally built applications in the past. So in the past, and even to this day, if you're not building single-page applications, you probably have something like this. You have a secured environment, your backend, that handles your service logic, your rendering, and basically your entire application stack. And then you have the entry point into your application, which is typically the browser. So say you have your applications, and we'll use Avengers.com for this example just to be topical. And you have a user coming to Avengers.com. Now, what the user is going to do once they land on your page, in their browser, is they're going to make a request to your backend. And your backend is going to look at this request. It's going to say, hey, does this user have the rights? Does this user have the permission to see the homepage? And in most cases, the homepage isn't protected. So the server is going to say, yes, they do. It's going to render all of that UI. It's going to render all of the presentation logic on the server, and then it's going to send it back to the user. Now, when the user logs in, they're going to typically get a session cookie set in their browser, and we're going to use that session cookie from then on to authenticate future requests. So can the user see the account page? Can the user see the checkout page? Can the user, update or delete their account? If they have a valid session cookie, you check against the database. Yes, they do. You go ahead and process the request. And in this case, your application is very secure because everything is done in this black box on your servers in the backend that nobody should have access to except you and your developers. But the modern landscape, and especially the single-page application landscape, is very different. So now we have a much smaller secured sandbox, our backend, and the front-end space, the client space, has gotten much, much larger. So with this in mind, we as developers, we're typically not building monolithic applications anymore. So instead of building an app or a server that handles both our logic and UI and presentation and all of that, we might just expose an API service that basically, you'll make a call to, and you'll get back a JSON or an XML or some type of response. So in this scenario, you no longer have Avengers.com, you have an API at, say, api.avengers.com. And now your user, it doesn't directly interface with api.avengers.com. They're going to come to your application. They might come to app.avengers.com or avengers.com. And this is a single page application. And it can be a React application, it can be an Angular, a Vue app, or it could be your own framework that you've written. But the flow is basically the same. And now we, as developers, as engineers, as product owners, we're typically no longer thinking of just having a single client that's going to interface with our API. So we might be thinking of a mobile app down the line. We might be thinking of an IoT integration, such as Amazon Alexa or Google Home. So we have all of these different front-end clients that don't contain any logic, that are only concerned with the user experience, the user interactions. And ideally, we would want all of these clients to talk to a single API, and they'll do that by making a request, typically via JSON. So we'll make an HTTP call, like a POST request or a GET request. If we're passing some data, we'll pass it in JSON format, and our server is typically going to respond, if the request is successful, with a JSON response. And you could do this via REST, you could do it via GraphQL, SOAP services. It really depends on your application infrastructure, but the important thing is that the flow is the same. So the question arises now, we have the secure API backend, we have these dummy front-end clients that are totally unsecured that anybody can have access to. How can we ensure that our app.avengers or that our mobile app can make secured requests to our backend, and only these apps can do so, and not anybody that knows that api.avengers.com is live? And the answer to that is JSON Web Tokens. So what are JSON Web Tokens? JSON Web Tokens, per the RFC 7519 standard, are defined as an open industry standard method for representing claims securely between two parties. And this definition kind of doesn't tell you too much. It kind of tells you what it is, but not really. So let's take a look at what a JSON Web Token looks like. That's even more confusing. So when I was first learning about JSON Web Tokens, I went through the very technical definition. I went and read the RFC spec. I looked at the different client libraries that implemented it, the different backend libraries. And it was just, one technical thing after another, and I was really confused. So what I want to do over the next few minutes is actually show how we use token-based authentication in the real world, and kind of tie it back to how we would use it in our single-page applications. So how are we going to do this? We'll use probably one of the most well-known token-based authentications in the real world, which is your driver's license. And the question I want to answer is, how is a driver's license like a JSON Web Token? And I want to see if we can make the analogy work, and see if we can kind of tie a driver's license to a JSON Web Token, and how we would use it in the real world and also in our applications. And the way we're going to do this is we're going to look at the different components of a JSON Web Token tied back into our driver's license, and then show a real-world scenario. So the first part of a JSON Web Token is its header. Now, the header of the JSON Web Token just contains some metadata, if you will, that tells you, hey, this is a JSON Web Token. This is basically what it is. So let's see what the header attributes are for our driver's license. If we were to look at the header for our driver's license, we can assume that the fact that it is a driver's license, physically everybody kind of knows what a driver's license looks like. And also, in this specific example, the state of New York is who issued this driver's license. So that's basically the header that tells us what it is. Now, if we were to look at our JSON Web Token, the header is actually this first part in green, starting with EY and ending in J9. So that is the header, and it's really just a base64 URL encoded string. So there's nothing fancy there. If we were to decode this particular string, we would get back a JSON object that has two properties. One, ALG, standing for algorithm, which is the hashing algorithm, or the cryptographic algorithm used to sign the token. And the second aspect is, or the second attribute, is the TYP attribute, which stands for type, which in 99.999% of the cases is just going to be JSON Web Token. So that's our header. Nothing too interesting there. The next part and the next component of a JSON Web Token is its payload. Now, the payload of the JSON Web Token is really the claims, the information that you want your token to contain and to transmit across the different parties. So let's look at our, no. So let's look at our driver's license and our JSON Web Token side by side. And let's look at the payload for our driver's license. So the payload is the different data that the driver's license contains. So it might be the driver's picture, it might be their name, address, demographics, such as their height, their weight, eye color, so on and so forth. And most importantly, their restrictions. So what type of vehicles can they operate? What type of vehicles can they drive with this particular driver's license? Now, if we look at the payload of our JSON Web Token, and the payload is the part in blue, and it starts with, again, EY and ends in FQ. And again, this is just a base64 URL encoded string, nothing special about it. And if we were to decode it, we would get another JSON object back that this time has 4 different properties. Sub, which stands for subject, which is essentially the user ID, given name, family name, and again, this admin property that set to true that tells us that this user, that the holder of this JSON Web Token is an administrator. So the payload or the claims within the JSON Web Token are very important, and there are different types of claims that you can make. The first claim you can make is, it's called a reserved claim, and there's only a small number of these, maybe 10 or 12, and these are claims such as the subject claim, the SUB claim that tells you who the user is. There's another claim called the ISS claim, which stands for the issuer, so who created the JSON Web Token. The EXP, the expiration time of the token, and so on and so forth. The second type of claim that you can make in a JSON Web Token is referred to as a public claim. And when it comes to public claims, these are claims that are, again, registered with the IANA, which is an organization that kind of keeps track of all of these standards and claims. And there's about 50 or 60 different claims, public claims, that are meant for API interoperability. And a lot of these claims are actually registered by the OpenID Foundation to make it really easy to communicate user identities across different applications. So 2 examples of public claims here are given name and family name. So typically you instead of using these 2 particular claims, you might have done something like first name or last name for your user, or F name and L name, but they kind of landed on this given name, family name nomenclature that kind of makes it really easy. So if you're also integrating with Facebook or with Google, their user data is going to come back and it's going to have a given name for the user's first name and so on and so forth. And then finally, there are private claims. And what private claims are claims that are very specific to your application and only mean something to your API. So in my example here, I have admin set to true, set to like a Boolean. Attribute true, but I could have represented this in any way I wanted to. So any valid JSON can be a valid claim. So I could have passed in an array of different permissions, different scopes that the user could do, and I could have used that to represent the different roles and permissions in my application. I could have used a string-based, admin true or false, or even like an integer-based 1, 0, 2, 3 for different levels. But I just used admin as true because my application is very simple. Now, the most important part of the payload in the JSON Web Token is that this is just a base64 URL encoded string. So anybody can, if they get a hold of this token, easily see the contents of it. So you never want to put any sensitive information in the token, such as credit card numbers or anything that you wouldn't want public. You don't want to put in the token, because if anybody were to get a hold of this token, they can see all of the data within it, and that would be very bad. So, where do we get the secure aspect of the tokens? That comes in its signature and its last component. So let's put our driver's license and our token side by side again, and look at what the signature or security aspect of our driver's license is. Typically, it is just a UV light hologram that's embedded on a driver's license. And I don't know if this is true in France, but typically in the US, when you go and get your driver's license, it has this little emblem on it that allows trusted parties to verify that this is, in fact, a valid driver's license that was issued by the government and not created by, a student in school. So if we look at the signature of our JSON Web Token, it is this last part in black, starting with UL and ending in GI. And to get this last part of the token, we actually run a hashing function to basically sign the token. And the way we do this is we take the header of the JSON Web Token, base64 URL encoded. We take the payload of the token, and then we run it through a cryptographic algorithm. And in this case, I'm using HMAC SHA-256. And with the HMAC algorithm, we're using a string-based password. So in my example here, I am passing in my header, my payload, and the password Loki sucks. And that's going to give me that signature at the bottom, and that's going to allow me to verify this token on my API server to make sure that the user that tries to make a request with a specific token, when I decode it and try to verify the signature, if it was signed with the password Loki sucks, I can trust the token. If it wasn't, I can reject it and say, hey, this isn't a valid token. So HMAC SHA is just one of the many cryptographic hashing algorithms, and we'll go through those in a little bit later. So let's see how we would use token-based authentication in the real world. So say Thor were to come down from Asgard and want to celebrate the Avengers making $2 billion or whatever it is. And he wanted to go to a bar or a nightclub or really just go party. And let's assume that he's in the United States where he has to be 21 years or older to do so. So what he would need to do is go to a government institution, fill out a bunch of paperwork, kind of verify his identity, log in, if you will, and then he would get his token. He would get his driver's license. And now when he goes to the bar or nightclub, he before being able to enter, the security guard out front would ask him, hey, do you have a driver's license so we can verify who you are? And Thor, since he does, he would give his driver's license. The security guard would look at it, run it through the machine to make sure that it is a legitimate driver's license. And since in this case it is, he would give Thor the thumbs up, and Thor would be able to go in and order a drink. Now, when he gets to the bar, he would have to do the same thing. The bartender would ask him for his driver's license, verify that it's still a valid driver's license, that it still works, and if it does, which it should, he would be able to order a beer or a drink or whatever he's having. But Thor doesn't really look like the kind of guy that would wait hours and hours and hours to get a driver's license. So he might go to a shady character, and instead of filling out his identity and kind of establishing who he is, he might just give this guy some money, and this guy's going to generate a fake driver's license for him that looks legitimate, that has all of the aspects that you would expect. It has the header, it has the payload, it has some type of signature on it. But now, when Thor goes to the bar, nightclub, presents his fake driver's license, once the security guard runs it through the machine or runs it through the UV light hologram, he would see that this driver's license has falsified data, it doesn't have the right signature, it doesn't have the right information, so he would tell Thor to hit the road, and he wouldn't be able to go in and order a drink. So that's how we use token-based authentication in the real world. Now let's tie it back to our single-page applications and see how it works there. So I'll put my API and my browser. So we have our server and we have our single-page application. And again, this works exactly the same whether you're building an Angular or a Vue or a React or any type of JavaScript application. Now, what the user does is when they land on the homepage, they make a request. And in this particular scenario, they're not logged in, they're not authenticated. But they landed on the page, and they made a call to this endpoint called SOS. So they're trying to make a help request. And the first thing our server is going to look for is the existence of a JSON Web Token in this request. And obviously, our user isn't logged in. We don't know who they are, so there is no JSON Web Token to be sent. So the server right away just responds with a status 401 unauthorized, telling us that, hey, we don't know who you are. You need to be authenticated to be able to do this. So next, what the user is going to do is they're going to log in. So they're going to hit the authentication endpoint, provide their username and password credentials, or log in with Facebook, log in with Google, however they log in. Once the server has authenticated them and made sure that it verified who they are, the server is going to issue them a JSON Web Token, and it's going to look very similar to the token we saw earlier. And it's going to have the header, the payload, the signature. And now our single-page application has this token and can go and make secure requests. So since the JSON Web Token standard doesn't really have a defined logo, I just use the Japanese open for business emoji, and we'll use that throughout the rest of the talk. So whenever you see that little emoji, that's what. Uh-oh. No. Let's see. Oh, there we go. So whenever you see that emoji, that'll be our representation of a JSON Web Token. So now we have our server and our application again. And now when the user makes a request to the version 1 SOS endpoint, they're going to append this JSON Web Token that they received with their request to the backend. And it'll be done in a new header called the authorization header. And it's a bearer token, so we pre-append the keyword bearer, add the token, and now when our server gets this request, the first thing it's going to look at is, hey, does this user have a JSON Web Token? And in this case, they do. So the server is going to say, okay, great. Well, does this particular JSON Web Token match the correct signature that we would expect? So does it have the password of Loki sucks in our example? And if it does, then great. Okay, so now we can trust the token. We have a token, we can trust it. Now let's look at the contents of the token and see, is the user authorized to make this request? Like, are they a member with the privileges of hitting the SOS endpoint? And if they are, then we'll finally go ahead and process the request and send a successful JSON response back. But if at any point our application, our backend realizes that, hey, this token doesn't have something correct in it, we're going to short circuit the request and send back a 401 or a 403 or the correct status code. So that's kind of how JSON Web Token authentication works in a very simple scenario. And we would do this every single time. So every time you hit a secured request, you would send this token with it. It would be re-verified. And if it is, we would send the successful response back. And then finally, to make it even a little more complicated, we would, sorry, what am I trying to get at? Yeah, so as long as you have a valid token, you're good to go. But the good thing about JSON Web Tokens and token-based authentication is that our server, our API server, doesn't have to be the server that is responsible for issuing and managing these tokens. We can actually do this in a third-party service, a microservice, and let's see what that would look like. Or actually, before we get into that, let's see what how we would actually append this JSON Web Token to our request. So in this example, I'm using the Axios HTTP client library on the front end. And so I'm making a post request to the SOS endpoint, passing in some data. In this case, I'm just passing in a JSON object that has a description. It says, help Thanos. And then I'm appending a new header to it called the authorization header, adding that bearer keyword, and then appending the token that I received from my backend. And since the token was there, it was verified. Once the function completes, that console log should send me the message OK instead of a 401 or a 403. But if we look at a little bit more of a complex scenario where we have our secured backend infrastructure, our API, we have our single-page application in the browser, and now we have an authorization server that's main concern is generating JSON Web Tokens and verifying user identity, it gets a little more complex. So we have our api.avengers.com, we have our app.avengers.com, and now we have a third-party service called login.avengers.com, or a third-party application, or a different application. And if you've used Google at any time, before you can log into YouTube or Gmail or Calendar, you go to accounts.google.com, you authenticate, and then you have access to all of the Google services. So this is kind of that scenario. So what would happen in this case is when the user lands in this blue section in your single-page application, the first thing they would do is click the login button and be directed to login.avengers.com, where they would provide their username and password credentials or log in however they log in. Once login.avengers has authenticated the user and made sure to know who they are, it would issue a JSON Web Token back to our single-page application. And now, at this point, our API.avengers.com is not aware that this even happened. It's not concerned with it. It doesn't care about user authentication or JSON Web Tokens. And so far it's totally oblivious that this whole thing happened. But now in our single page application, we have a valid token. So when we go to make a request to API.Avengers, if we're trying to hit that SOS endpoint or a different endpoint, what we're going to do is make the request and append the token with it. And at this point, our server is going to look at the request, ask for the token, verify it, make sure it has all of the right claims data. If it does, it processes the request and sends back the JSON data, and our single page application can render it properly. So this is kind of a complex scenario, but a common question that I get at this point is, where do you store this JSON Web Token? Because you have to send it with every single request to the backend. And at this point, we're not persisting the token anywhere. So every single request, you basically have to go and log in, get a token, and then make the request. And if the user refreshes the page or opens up your application in a new tab, they have to log in again. And this is a very crappy user experience, and definitely something we wouldn't want to do in the real world. So how would we get around this? Well, let's look at our 3 applications again, or our 3 different environments. And basically what we would do is when the user lands on our single page application, clicks the login button, the process is very similar. They log in, pass in their credentials. Once they're authenticated, though, before we issue the token back to the single page application, we actually set a session ID cookie on the authentication server that's going to help us identify this user later on in the future. And then we issue the token, send it back to our single page application, and the process from there on is basically the same. And this is very important because at this point, in your single page application, you should not be storing the token and persisting it anywhere other than in memory. So when I started working at Auth0 a few years ago, a common thing that we suggested on our blog was that you take your JSON Web Token when you receive it from the authentication server, store it in local storage or session storage or a cookie, and that way you can always access it and you don't have to keep logging in and you can kind of persist the user session. But that's not really a good thing to do, because if your application, your front-end application, becomes susceptible to a cross-site scripting attack or a cross-site forgery request, then a malicious user can actually steal your authentication token, your JSON Web Token, and then they can impersonate your user, and your backend will have no way of knowing if this token is from the trusted user or from the malicious user. So with that in mind, we do not recommend that you store the token or persist it anywhere in your application. And if you must, do it in memory. So if you're using React, you might store it in like a Redux store or just in data. So if you were to refresh the page, that token is gone and your user has to log in again. But again, even if you were to do this, you would still have that really crappy user experience of, well, if the user opens up the app in a new tab, or if the user refreshes the page for whatever reason, they're logged out, and we wouldn't want this to happen. So is there a way around doing that? And the answer is yes, there is. And let's see how we're going to do that. So we have our application again, our API, our single page app, and our authentication server. And now, since the user logged in previously, we have this session identifier. We have this cookie that tells us this user is logged in. So what we're going to do when the user refreshes their page or opens it up in a new tab is we're actually going to make a silent authentication request to our authorization server. That looks a little something like this. Basically, what we do here is we create an iframe in our single page application, make a request to the authentication server to see if the user is authenticated. Once this request gets to the authentication server, we examine the cookie on the back end, make sure that it's still a valid cookie, and we can identify who the user is. And if we can identify who the user is, we'll issue a new JSON Web Token to the single page application and let the user go on from there. And the way that this silent authentication request works is it's an iframe request, and we use the post message API to basically, once we receive a successful request in that iframe, we'll just push it up to our single page application from the iframe, and then our single page application will handle it from there and assign the new cookie or the new token. So that is a very, very complex example, but that is the most secure way of doing single page application security. because you wouldn't want to do, or you wouldn't want to handle user authentication in your single page application, because even if you're using Angular or React or any of these big frameworks, you're still pulling in so many different dependencies from npm that I guarantee you none of you guys, and neither have I, have verified to see if they have any vulnerabilities, if they can execute remote code, because if at any point they can, your tokens can be compromised, your authentication system can be compromised. So doing it in this manner where you have a separate domain to handle user authentication is a really good security practice. And still good. So some additional resources, if you guys are interested in learning more about JSON Web Tokens or considering using them in your applications. General, quick intro just like this, you could find at jwt.io. And there you can actually put in your JSON Web Token, decode it, and kind of see what information is within it. If you are interested in learning about the different JSON Web Token signing algorithms, the cryptographic functions, we've written a really cool blog post on the Auth0 blog. So you could find it by going to bit.ly, jwt-alg. And if you guys are totally sold on JSON Web Tokens and want to learn all of the ins and outs, we have the JSON Web Token Handbook, which is a free ebook you guys can download, written by my colleague at Auth0. And this book will tell you everything you've ever wanted to know about JSON Web Tokens and more. It's a really interesting read if you are interested in the technology and want to learn all the ins and outs. And to summarize the talk, single-page application security is mainly concerned with authorization. So since we can't have any private data, any API keys, any secret information within our single-page application, we really can't have security there. But we must have a system of authorizing our single-page application to talk to some secure backend or server. And JSON Web Tokens are really excellent for this scenario. And then there are many excellent JSON Web Token libraries that exist for all languages and frameworks. So whether you're building a single-page app, on the front end, we have like Axios, HTTP client for Angular, Fetch API, XML HTTP request. All of these really support managing and sending header requests. And then on the back end, to validate these JSON Web Tokens, whether you're building a Node app, a Java app, a C# app, a Go app, whatever your backend is, there's already a plethora of frameworks that libraries that you could pull in to really simplify this for you. And then finally, a security guard probably couldn't stop Thor from getting into a bar, but your server can most definitely refuse requests that don't have valid and proper JSON Web Tokens. And with that said, thank you guys very much. I'll be, I don't know if we have time for questions now, but I'll be around all day today and tonight, so find me and say hi. Thank you.
We might take one question.
Thanks for the talk.
Sure.
Do JSON Web Token ever expire, or can we revoke them?
Yes. So when you issue a JSON Web Token, you can set an expiration time on it. So you can say, this token expires in 10 minutes or 1 hour or 3 hours, however long. And after that point, that token becomes invalid and your server is not going to accept it anymore. When it comes to revoking JSON Web Tokens, it's a little more complex. So you can create a token blacklist on your API server that's going to look for specific attributes. So it might be like an email or a user ID. And if a token comes with that particular information, you can revoke it. And you might want to do this in the case of, say you had an employee that joined the company and they were fired the same day, but they logged in and received an active token. In that case, if the token wasn't expired and they still had access to it, they could access your servers. But having that blacklist could limit the exposure.
Thank you. We're going to have a coffee break, like for 30 minutes, and then we'll be back for the rest of the conferences.
Awesome. Thank you, guys.